So, welcome everyone, welcome to the Smart Interviews YouTube channel. Today we are going to discuss problems from CodeChef Starters 132 or Division 3. So, let's get into it. So, looking at the first problem, this problem is called as change please. And here, let's go to the problem statement first. We are traveling in a cab and we owe the driver X dollars. We have to pay him X dollars, but we have only 100. We only have $100 bill. So, and it also says that the driver only has $10 bills, so he can pay through those $10 bills. So we give those $100 to the driver, and we have to find out maximum amount which the driver can pay back to us with the given without giving anything extra to us. Okay, without giving anything extra, how much he is going to return us is the question. Okay, so looking at the example, the first example says that the cost is 90. So total we have $100. We gave them that. So after subtracting, we would get 10 back. So 10 is the output for this. For 100, nothing is remaining. For the third test case, we gave him $100, out of which 66 is the cost of the fare. But since he cannot give us the 60, sorry, since he cannot give us any change and he has only $10, he would round it up to 70, and or the remainder that we have if is 33, right? But because he cannot give us the 3 units in change, he would give us $30 back. So that is the question. It is quite simple. By just looking at the example, we can say that we all just have to round up the remainder, right? If we can round up the remainder, that will be the amount that is that the driver is going to give back to us. So the formula should just be the amount of input. Let's say x, sorry, 100 minus x. Okay, it will give us some remainder. To round it up to the units, what we can simply do is we can perform, let's say 33 is our output, we can perform division with 10, integer division with 10. So we'll get 3.3, and sorry, integer division, right? So we'll get 3, and we'll again multiply it with 10 to get 30. So that would be our output. Let's just code it up and see how it works. So we'll run the code. First, we are given t test cases, so we'll run a for loop for that. Okay. After this, we have x as input, so we'll take the input of x. So as we discussed in our solution, we have to just print remainder by 10 into 10. So the remainder is 100 minus x, and we'll divide it by 10. So this entire thing we'll divide it by 10, and at last we'll multiply it by 10. So this should be our answer. Let's just run this. Yeah, we are satisfied with our sample test cases. Let's also submit it and check. So yeah, this was a quite simple question. Let's move on to the next one. So let's look into the next question. The second question is called as game level. So here we are given a list of in batsmen and M bowlers, and each of them are having some cricketing skills. And the selectors asked us to pick a team of 11, such that there are at least 4 batsmen and 4 bowlers there. Okay, so we have to find the maximum total cricket skills of the team, which we can form by picking the batsmen and bowlers to form a team of 11 players. And he's just saying that the total cricket skill is the sum of the cricketing skills of players that we take in this team, and we have to print -1 if it is not possible for us to make a valid team. So for making a valid team, few things: we need 11 players, right? We need 11 players, and in that we need 4 batsmen and 4 bowlers. So without these conditions, we can say that our team is an invalid team. So will print -1 in that case. Okay. So now let's also look at an example. So now we have to make a team of 11 players. So first of all, we need 4 batsmen and 4 bowlers. So we'll pick 4 from here and 4 from here. And the question has to give us the maximum total cricketing skills. So it would be better for us to pick the maximum first in both the areas. In both the areas, we'll pick the players with maximum skills. So in this array, it will be 6, 5, 4, and 3. So in the second array, again 6, 5, 4, and 3. So this adds up to be, it would be 18 here and 18 here. So 36 is the total skill till now. And we picked 8 players. 8 players are done. And we have to pick 11 minus 3. So 11 minus 8. So 3 more players. Okay. So we have to pick 3 more players. So and we are done with 5, 3, 4, and 6 here. And same here. So out of the remaining players we have to pick 4 players so that our total skills will be maximum, right? So simply let's go to the batsman first and check what is the highest in bowlers and batsmen, and we'll try to pick those players. So if you see 2 and 2 are actually same, so what we can do is we can simply pick any one of them. So let's say we pick this and we'll add 2 here. Next available is 1. So between 1 and 2, 2 is larger, so I'll pick this. So plus 2 here. Next 1 and 2, we'll pick 2. So it would be 42, and 42 is our output. And here if you see, we pick the next 3 players, right? We pick the next 3 players. And if you look at it, the logic is quite simple here. So we'll pick, since we need the maximum, what we can do is we can take the batsman array and bowler array and sort them in reverse order and pick the first 4 elements from each of them, and we can selectively pick the next 3 values. We can selectively pick the next 3 values from the remaining elements in the array. So that is our main logic to solve this question. Let's code it up and check how it runs. Okay. Yes, let's get to the coding part for this question. So first, if we look at the input format, there are t test cases for us. So we'll just run a loop for t times. Done. Next, what else do we have? We have n comma n as the input, n comma n. We'll take the input of that map of int comma input dot split. So input of n comma n, done. Next we have the 2 arrays. First we have batsman array and bowlers array after that. So bat equals to list of map dot split. So this is the array for batsman, and yeah, batsman is this, and bowl is this. Okay, we are done with our input. Now let's just handle the invalid cases that we discussed before. So if the total number of batsmen are less than 4, or the total number of bowlers are less than 4, or total number of players that we have are less than 11, if any of this is true, we'll just print -1 and continue to the next case. So this is the invalid state. Next, if that is not the case, we'll go with calculating our answer regularly. Okay, so we'll go with calculating our answer regularly. So the first thing we have to do is pick the maximum element. So what we'll do is we'll sort our arrays in reverse order. So bat We'll sort it in reverse. So we'll sort bat and bowling arrays in reverse. So reverse. Yeah, we sorted in them in reverse order. Now we'll first pick eight total of eight members from these two arrays. So I'll run a loop for four times, and I'll add the values to answer. So bat of I, and similarly we'll also add the baller to the answer, ball of I. Okay. So after this is done, our task is to pick three more, right? Because eight are done here, we need to pick three more values. So for I in range 3, so this loop is going to run for three times to pick three players. So what we can do is we can, you know, we can declare two variables p1 and p2. So these are going to keep track of indices of players. Okay, these are going to keep track of the indices of both player arrays. Okay, now so if let's say p1 is less than n, so we did not exhaust the value, and bat of p1, okay, first we'll check if p1 and p2 are in range. So if p1 is less than and p2 is less than n, sorry, m. Okay, if p1 and p2 are in their ranges, now we can simply check if bat of p1 batsman skills are less than bowler skills. So batsman is not valuable to us, so we'll add this bowler to our answer, ball of p2, and we'll increment the value of p2. Okay, so if both we have enough players in p1, batsmen and bowlers, we'll just pick the larger one and add it. So else answer plus equals to bat of p1 and p1 plus equals to 1. Okay, if if one of them is exhausted, we can just go with the remaining array. So if that is not the case, if one of them is exhausted, that is if p1 is greater than or equal to n, then we'll just add the value of p2. So answer plus equals to bowl of p2 and p2 plus equals to 1. Else we'll add p1 to the answer, so bat of p1 and p1 plus equals to 1. So this is our code, and at last we'll print our answer. So let's run this. So we got our answer 4266. So let's, after running this, we got 4266 and 1 as our output. Let's submit this and check. So all the test cases are passed. So this was a simple question actually. So all we had to do was linearly iterate and pick our players. Okay. So let's move on to the next question from here and try solving it. Let's start with the third question in div 3. So the question is called as alien or. So, and let's go through the question first. We are given two integers n and q, and we have an array of size n where every integer is a binary string of size k. So if k is 3, we have n elements and all of them are binary strings or having of size k. Okay, now our task is to find whether there exists a set of indices, or we can take elements from the array, set of elements from the array, such that the decimal value of or of all those elements that we took equals j, and j can be, j is nothing but a value between 1 to 2 power k. Okay, and here the line pipe represents bitwise or. Okay, so that is the question. Let's try to understand it a bit better. So what the question is asking us, we are given binary representations. Also, we are given a total of n numbers, and they are nothing but n binary representation of numbers. And at max, not at max, they are they are binary strings of size k. Now our task is that we have to generate. Our task is that check if we can generate every value from 1, 2, and so on up to 2 power k minus 1 by using the above values. How do we use them? What we can perform is we can select some values in the array that are given to us, and we have to perform bitwise or on them and check if we can generate all values between 1 and 2 power k minus 1. That is the question given to us. Let's just look at the sample example, and we will try to understand it even better. Now, so we are given first sample case. If we see, there are two binary strings of size 2, so k is 2 and n is also equals to 2. So the binary strings given to us are 0 1, that is 1, and 1 0 2. So this is the binary value, and this is the decimal value for these things. Okay, now we have to generate all values from 1 to 2 power k minus 1, that is 1 to 2 power 2 minus 1 is 4 minus 1, so 3. Can we generate all values from this if we can perform or of these two values or any combination of or? Okay, so first 1, so we have 0 1, which is a binary representation of 1, so 1 is done. Next 1 0 for 2, 2 is done. For 3, what we can perform is 0 1 or 1 0. Okay, so if we perform this, we'll get 1 1, which is nothing but the binary representation of 3. So this is a yes. Okay, so first test case is giving us yes because we can perform these operations. Now let's look at the next test case, and it says no as the output. Okay, so we have 0 0 0, so 0, 0 1 0, so this is 2, 0 1 1 is nothing but 3, next 1 0 0, this is nothing but 4. Okay, we have 4 values. Now using this, can we generate one? Because we are using or, like if you look at binary representation of 1, it is 0 0 1, and if you see 3 is an element which has the 0th bit position as set, right? But since we are applying or, we cannot remove any of these bits, right? What is the situation, what happens when we do or is, when you have 1 in any side of the input, if you perform or and you have a 1 in the input, then the output is of course going to be 1. There is no other way possible, so it is not possible for us to generate one. So first test case that we look at is 1, and we cannot generate one, so the answer is simply no. Now how do we solve this? Can Should we generally brute force, check if we can, if any possibility of numbers from the array gives us 1? I don't think it is very optimal, and it is complex to even code, right? So what is our logic? Now, if you know how numbers are represented in our computers, they are generally represented using binary representation, right? So as we know, all numbers are represented using binary format, right? So first value is 2 power 0, second value is 2 power 1, 2 power 2, and 2 power 3. So if we have k bits, if we have k bits, we have powers from 0 to 2 power k minus 1, and using these we can generate all other values. That is how we represent numbers in our computers. But if I have, let's say, 0 1 1, can I generate 2 power 0 from this? Here I have 2 power 0 as set and 2 power 1 as set. Since I'm using OR, this bit that I'm having will never be unset, right? If I perform any operation, this will never be unset, because OR should have at least one. If we have one on one of the inputs in OR, our output will be one. So if we have something like this, we cannot get the value of 2 power 0. But if we have the value, all the values of 2 power 0, 2 power 1, and so on up to 2 power k minus 1, we will be able to generate all the values from 0 to 2 power k minus 1. Okay, if we have all these values in our array, we will be able to generate these values, right? So this is our main logic. All we have to do is we have to check if all the values are present, and we can figure out if we can generate all the values. Okay, so that is the main logic that in this question. So let's go to the code and see how it works. We'll try to implement the same logic in terms of code and check how it works. Okay, so let's come to the code part. First, we are given t test cases, so we'll run a loop for t test cases. Next, we are given the values of n and k. N comma k is equals to map of int comma input dot split. Okay, then we have n inputs, right? And as we said, from those inputs, we will try to check if we can get all two powers from 2 power 0 to k. So to count those, what we can simply do is we can maintain a set so that we don't count the same things again and again. So let's say S is a set where we'll add all the two powers that we find in the array. Okay. Next, let's run a loop for n times, and in each iteration, let's take the input. So x is, we'll just take the input, not integer of input. Yeah, it is a string, right? Now, all we have to do is check if x is a 2 power. So let's say is 2 power is a function for us, and if it returns true, we'll add the value to the set. Okay, if it is a 2 power, we'll add the value to the set, and so on. Now at last, what we have to do is check if length of the set is equals to k. So the total number of two powers that we find should be equal to k. Then our answer is done. So if that is the case, we'll print yes, else we'll print no. Okay, so that is the main logic. Let's also try to complete the is to power function. Is to power, and we'll pass the value of x. So if you look at the powers of 2, they are simple. They only have one set bit in them. So all we have to do is check if there is only one occurrence of 1 in the given string x. So what we'll do is we'll just return x dot count of, so we'll count the number of ones in the string, and it should be equals to 1. If that is the case, that is a 2 power. So we'll just run our loop, so run our code. Let's check what we get. So yes, no, yes, our sample test cases are satisfied. Let's submit it and check. Okay, so The question seems intimidating, but it is quite simple. All we had to do is look how binary representations are actually done, and we get our answer easily. So this is the answer for the third question. Let's move on to the next problem. So let's start discussing the fourth question in the course of Div 3. So the question is called as optimal flip, and let's just go through this question. We are given an array of length n, and we can perform this operation at most once. So we can pick an element in the array and we can increase it by 1. So if we can increase it by 1, we have to find the maximum count of subarrays having at least one even element after performing the operation at most once. That is, we can skip performing the operation, so we can do that operation 0 or 1 times. Okay, so what is the maximum count of subarrays having at least one even element? Okay, so that is the question given to us. This is the input format, pretty straightforward, and we have to print the count, maximum possible count. Let's look at the example once. So the example says, without performing the operations, we have 2 as a subarray, 2 1, 2 1 3, and 2 1 3 4, where we have at least one even element. We can pick 2 as the even element, right? So 4, next we have 3 more subarrays, so total 7 subarrays before performing the operation. Next, after performing the operation, that is, we can make this one as 2, so it will be 4 starting with 2, and 3 starting with this index, that is index number 1, 3 starting with index number 1, and last 2, so total 9 subarrays. There are 9 subarrays where there is at least one even element. So this is the question given to us, and we have to find output for it. Now let's try to solve this question in uh, some steps. Okay, so first step that everyone that we need to know is, if I have a array of 5 elements, uh, how many subarrays do I have? Okay, so we cannot keep counting like this, right? It would not be optimal, because if you want to generate subarrays, the n value is already 10 power 5, and if you use more than one loop to do that, to count all subarrays, it is not going to be optimal. So what we'll do is we'll try to figure out a formula for this. So first of all, we have 5 elements, so number of subarrays starting with 1 is with the first element, so 1 2 3 4 and 5. So number of subarrays starting with 2 is 2 1 2 itself, and 2 3, so 4, so 5 plus 4, like this we have 3 plus 2 plus 1. So from this we can say that this is 5 into n plus 1 by 2. So total we have 15 submarines, right? So if I give you an array of sizes, there are going to be n into n plus 1 by 2 subarrays. So that is done. So we know how to count number of subarrays. Now first, to solve this question, what we'll do is, first let's count how many subarrays are there, without making any changes. Okay, without making any changes, how many subarrays are there? Subarrays, subarrays without the operation, without performing any operations. Now we need at least one even element in the subarray, right? We need at least one even element in the subarray. So let's take is the example and add some elements to it. 3 4 5. Okay, so one thing I can surely say is, when I iterate through the array and find a even element, I can say that there are going to be let's say this is I, there are going to be n minus I subarrays that are definitely having an even number. That is, every subarray starting with 2 is going to have, every subarray starting with 2 is going to have a even element, right? So in this case, the total number of subarrays is 5. Next, in case of 1, I don't have uh, subarrays starting with 1. I don't know how many even are there. So starting with 1, there are 0 till now. 3 0. But starting with 4, how many subarrays do I have? Even with consisting of even. So 4 is 1, and 4 and 5 is one more subarray. So plus 2. Now if you think about it, since 4 is an even element, since 4 is an even element, the subarrays starting from previous elements which are odd, well, since 4 is an even element, they can also form even subarrays, right? That means I have 4 and 4 5 as subarrays which include 4. So similarly, I'll have two subarrays, 3 4 and 3 4 5, right? 3 4 and 3 4 5. Similarly, I'm going to have subarrays 1 3 4 and 1 3 4 5, right? Because since 4 is there, 4 is an even number, the previous all odd element containing odd element starting subarrays, since 4 is coming, they also contain a even element, right? So the number of, can I say this as simply the number of subarrays starting from the even element. So n minus I subarrays starting from even element is going to be 4 and 5, plus the number of odd consecutive elements before this, that is 2 odd consecutive elements into 2 odd elements in the array into n minus I. Because if you see, all these subarrays have 4 5 common, right? That is the total number of subarrays starting with 4, and how many previous elements are there, we'll just multiply their count with the subarrays. So in this case, it will be n minus I plus 2 into n minus I. So all we have to do is we have to linearly iterate. Uh, let's try to do that. We have to linearly iterate, and if it is even, directly add this to the answer. So if it is even, directly add it to the answer. But if it is odd, we will make changes and add them to the answer. Okay. What are the, but if it is odd, not make changes, we will maintain a count. So we have one odd variable, count is 1, next count will become 2. Again, whenever we find even, we'll add the even value plus the count into the number of subarrays starting with this even value, and we'll get number of subarrays without any operation. Okay, without any operation. Now let's come to the third part. If we perform the operation, how many subarrays do we get? So coming to the third part, how many subarrays do we get if we perform the operation once? Let's come to the third point of our solution. So what odd element should we change so that we get the best answer? Okay, first of all, we are leaving out odd consecutive elements, right? We are leaving out odd consecutive elements. These are not generating subarrays. So out of these two, which one will give us better answer? Let's try to check. No, let's try to figure out. Let's say if we make this one as even, let's make this one as even. So we form two new subarrays, that is even and even odd. Okay, so that is the case. Now if we go to the second cluster of odd elements, if we make this one as even, in this case we make three more subarrays, right? So from this we can simply say that it is better for us to go with larger uh, continuous odd elements, a larger cluster of continuous odd elements, and change elements in them to get better answer. So maximum continuous odd elements is the better way to go with. Now out of these, which one will give us better answer? Is changing first one going to give us better, or second one, or third one? We have to look at that too. So what if, let's say we have five odd elements, odd 1, odd 2, odd 3, odd 4 and odd 5. Okay. Now if you see, if we change the first odd element, it is simply odd. This is going to be even, right? Even, and we are going to have, five more new subarrays. Five more new subarrays, that is this. But what if we change the second element? So if we change the second element to E, it will be E, even odd odd, and even odd odd odd. So four more summaries. But we also remember, we just discussed in point to that. Not only these, but we will also include the summary starting with O1, right? O1 E, next O1 E odd, O1 E dot dot, or O1 E dot dot dot. So 4 here and 4 here. So it is better for us to go with second element than first element. Similarly, if we go with the third element, what will that be? 3, already starting with O3, into 2 more, or plus 2 more starting with O1 and O2, whose sizes are, sorry, which contain O3, which is nothing but the new even element. So in this case, it will be 9, right? So if we go on like this, the best option that we can take is the middle element, because when we try to change the fourth element, it will be the size of the subarray. The total number of new subarrays we get is 2. The total number of new subarrays we get is 2. And how many do we have? 1, starting with O1, O2, O3 and O4. So in this case 8. So again it is same as O2. When we start with O4, it is same as O2. And if we start with O5, it will be same as O1. So it is better to go for us with the middle element. And if you try to generalize a formula here, so number of subarrays starting with O1 will be 5, that is n minus its index, right? N minus its index, zeroth index, into how many previous odd elements are there. In this case 0 and 1 O1 itself, so 5, and so it will be 5. In case of 2, it will be 5 minus index 1, so 4 subarrays, into how many are there starting with O1, O2, and how many are there here, that is O2 itself, and O1, O2 are the starting points. So 4 into 2. So for odd length, if we look at it, it is the best option is 3 by 3, right? 3 into 3, which is giving us 9. So here we can just write n by 2 plus 1 into n by 2 plus 1, or n by 2 plus 1 whole square. When it comes to even, and if you look at the pace which they are going, let's say n equals to 6, so it will be 6 into 1, next 5 into 2, 4 into 3, again 3 into 4. So this is our best option. So it will just be n by 2, that is 3 plus 1, into n by 2. Okay, so if we follow all these steps, and okay, If we follow, if we just remember what we did here, we know how to generate all subarrays. Okay, and how to generate subarrays, with odd elements in between, and using the same logic we'll pick the largest cluster and add the new subarrays generated. Okay, let's implement the same logic in code and let's see how it goes. Okay, let's start with our code. We have t test cases, so we'll run t test cases. Next, and so int of input l, the list given to us. So the best possible case where we don't have to do much is if the odd element is count as 0 or it is 1, right? In that case we don't have to do much. We can just use the formula to count number of subarrays. So we'll take a variable called o to count number of subarrays and we'll run a for loop. Okay, in range, in for I in range of n, we'll check if the array element is odd, then we will increment the count of O. Now, if our O is less than or equals to 1, O is less than or equals to 1, that is, we don't have to do much here. So we'll just print the number of subarrays that we can generate, that is n into n plus 1, and we will divide it by integer division by 2, so n into n plus 1 by 2. Okay, and our solution is done with it, just so we'll just continue. But if that is not the case, we'll go with our general discussion. How many subarrays are there? So answer is we'll initialize it with 0, and maximum consecutive odd elements are also 0, and I'll declare a count variable to count consecutive ones, and I'll declare it with 1. Okay, now let's just iterate through the array and find number of subarrays with one even element, not in range of input but in range of n. Now if L of I is even, so if L of I is an even number, so we'll directly add number of subarrays starting with even. So it is simply n minus I subarrays starting with that number, and we have, if we have any odd elements before, simply into c, and we will reset the odd count into to 1. So if that is not the case, we'll update the maximum odd elements count, consecutive elements count, that is max of mco comma count. So let's declare count as c, then let's just declare count as c, and we'll increment the count because we found a odd value. Okay, so this will give us the number of subarrays the question is asking for without any changes. Now for the remaining part, we already discussed, we have a we have generated a formula, right? So if the maximum consecutive odd values length is even, in that case, as we discussed, we'll just use the formula answer plus equals to MCO by 2. We'll add 1 to this, MCO by 2 plus 1 into simply MCO by 2. Okay, so this will give us the best answer. Let's also keep this in braces. So this is giving us the best maximum subarrays that we can add if the consecutive odd elements are in even length. Else, as we just discussed before, for odd lengths it is simply MCO plus 1 by 2, and we will square this. So this should give our answer. So we'll just print our answer here. Let's run the code. Check this. So sample test case is working. Let's submit this. So yeah, this is the solution. Uh, this is the solution for the lead code optimal flip question. Uh, so this is how we solve the optimal flip question given to us in CodeChef Starters. Thank you for watching the video.